Today we're going to wrap up first unit of the year, Chapter 4, Quadratics, solving, all that stuff that we're going to learn about the last method that we're going to explore in this chapter, and that's called the quadratic formula. We're going to use the quadratic formula to solve a quadratic equation, and you will be able to use the discriminant, which is part of the quadratic formula, to determine the number of real solutions to a quadratic equation. So, let's look over what is the quadratic formula. You have to learn that first. Okay, the quadratic formula is this big, scary looking thing here. So if we take the general form, y equals ax squared plus bx plus c, and we take those coefficients a, b, and c, we can plug them in the formula. X equals negative b plus or minus square root b squared minus 4ac divided by 2a. You can have two real solutions, one real solution, or two imaginary solutions. I suggest there's a couple of cool videos you can, I'm not going to click on them in here and go to them. I don't want to waste time on the lesson here. We'll probably play them in class tomorrow anyways, but if you want a sneak peek, it's a catchy little, some of you may even think it's annoying, but whatever works to get that formula in your brain and memorized. So watch them. They're somewhat entertaining, probably a little more creative way than how I normally would have approached getting you to memorize the quadratic formula. So take a look at those. You can also you can have two real solutions, one real solution, and two imaginary solutions. We talked about that. When you have two solutions over here on the far left, you can see the two dots where the graph crosses the x-axis. We talked about that already. If it crosses twice, there's two solutions. If it crosses one time, you see in blue, it can cross going up or going down. Those are two different equations graphed at the same time, not the same one. But if vertex is on the x-axis, then there's one real solution. If the vertex or no part of the graph touches the x-axis at all, as it is in the far right, unlike the middle or the left, the far right it never touches, those are two imaginary solutions. We've talked about that. We've seen what that looks like already, both in the notes and in class. So this is kind of an idea that we've discussed already. If you didn't get a chance to get this down, pause it. This is the quadratic formula. Please write it down. You will need it. So not all equations can be factored. Not all equations can be solved by square rooting. Maybe not all equations can be solved by graphing. What it boils down to is some of them you either have to use completing the square, which you may or may not have enjoyed last lesson, or the quadratic formula. The quadratic formula, just so you know, I used to use this as my crutch. I was not very good at factoring in high school. So if you've been going through and factoring has just not clicked so far, I hope it has, because the way I taught you was way different than how I learned it. Using bottoms up, I hope that's clicking for you and making more sense than me, which is a lot of guess and check, and I didn't like that as much. But the bottoms up should be clicking. But if you want an alternative, if bottoms up isn't your favorite thing to do, quadratic formula is good in the sense that it will get you to your right answer every time, but it is more cumbersome. There's more steps to it. If you're really good at factoring, you're not going to like quadratic formula as much. And quadratic formula, we learned this last because I would rather you try and factor first to solve when you just have a problem. But we're going to practice quadratic formula today. If you think you can factor it, try factoring and see if you can get the solution as well. So for this one, two real solutions, x squared plus 7x minus 6. We'll see if that's the case. We want to solve the directions. He doesn't say it, but I want you to solve this equation. So you might try to do, if it just is just a problem out of the blue, you might do bottoms up method. Let's just do quadratic formula just to check and see if we can do it and try plugging in it. The formula itself, it looks scary, but really you just have to copy it down. And you have to identify what A, B, and C are. If you can identify A, B, and C from your equation, it's straightforward and it's a piece of cake. So remember, it's ax squared plus bx plus c. So if I go through this, the opposite of b, that's a minus b, opposite of b. B in this case is 7. So we're going to find wherever we see a b with a 7. So the first one, the opposite of 7, plus or minus square root, and And I'm going to put 7 in parentheses just in case it were negative. We'll do it over here as well. Minus 4 is always in there. That number 4 is always in there. A. We don't see a number in front of x squared, so A is 0, right? Wrong. A is what? Again, if there's no number in front, A is 1. That's right. C is negative 6. We're multiplying 4 times A times C. 4 times 1 times negative 6. All over 2 times A, which is still 1. So all I did is I found what A, B, and C were from my equation, from my expression, plugged it in. And now I just have to do some simplifying. I would start by simplifying the square root part. Don't put the square root in your calculator. I'm going to show you how to do this. We're just going to put the part under the square root sign. We're going to have a special name for that in a minute. Okay, but the part under the square root sign, that's what we'll call it now. We're just going to put b squared minus 4ac, which in this case is 7 squared minus 4 times 1 times negative 6. We get a positive 73. So we're going to simplify all that to a positive 73. And obviously opposite of 7 is negative 7. I dropped the parentheses there. So square root of 73 over 2. And so now we see if we can simplify this at all. 73 I don't think will break down. Make your list of perfect squares, but there isn't a perfect square that, as far as I know, that will divide it. But check against it. Make your list of perfect squares, 1 through 10, square all those numbers. See if any of the perfect squares divide it. I don't believe they do. So this would be your answer. You could also write it, you split it up, negative 7 plus the square root of 73 over 2, and negative 7 minus the square root of 73 over 2. You could also split it up in negative 7 over 2, square root of 73 over 2, plus and minus. Why do I write it this way at the bottom? On your test, quite possibly, you may see it listed this way as a multiple choice answer. So you have to know that these two forms are equivalent. They mean the same thing. So just keep that in mind. Okay, so not so bad, huh? So we noticed we had two solutions. The part underneath the square root was positive. Keep track of that as we go through here. We're going to skip this one. Let's go down to one real solution. One real solution, we're going to do the same thing. Okay? And you're probably thinking, well, we could factor out a 2, and you're seeing that. That's great. Let's pretend we don't see that. Does it matter if we factor it out or not? It does not. We can just use A, B, and C as is in the problem. So we don't have to reduce anything for quadratic formula. Just use A, B, and C the way they are. The only thing you have to do is you have to have the equation set equal to 0. So if the equation is not set equal to 0, this is like factoring in that regards. You have to manipulate the equation a little bit in order to make the quadratic formula work properly. So A, B, and C are B is negative 8. That's why I put in parentheses before. The opposite of negative 8. We don't say, oh, well, there's already a negative sign there. I don't have to bring it over. Yes, you do. And that's going to be a mistake people make. They go real fast, and it's a negative 8, so they don't put the negative there, and they just have negative 8 instead of, as you can see, opposite of negative 8. That's going to cancel it out to be positive here in a minute. So negative 8 squared, put that in parentheses as well. You'll see why, hopefully already. If not, you'll see in a minute. A times C, 2 times 8, divided by 2 times 2. So once again, I'm going to start by what's underneath the square root sign. I am not going to put the square root in the calculator. Okay, some people do, but if it's not a nice, like 73 is not a perfect square. If you get a number like that, it's not going to work out for you so well. So you have to do it in steps here. I know we want to just put it all in at once and be done with it, but there are some steps we need to do. 8 squared minus negative 8 squared minus 4 times 2 times 8 is 0. Okay. Opposite of negative 8 is 8 plus or minus the square root of 0 over 2 times 2, which is 2 of 4. So what is the square root of 0? It's just 0. So really this part is gone. We just have 8 over 4, which is 2. So 2 is the only answer. Now, of course, we didn't do that in the last one, but we should go back and check our work plug it in. Make sure that 2 actually works out as a solution. 2 times 2 squared. Remember, there's multiple ways you can check it, graph it, use the table, use the value function. You know, there's lots of ways there are lots of ways to do it. It's whatever works for you. I try and do a different one, different time, just so we're aware of all of them. You make sure you check it, but it does work. Okay, so we had one solution here, right? One solution. Anybody notice what happened to the square root part this time? What did it equal when we had one solution? Equals 0. It went away. So one solution, there was nothing under the square root. It was 0. 2 solutions, underneath the square root was positive. We're going to do 2 imaginary solutions now. What do you think is going to happen? That's right. Probably going to have a negative square root. So if you want to, you can try and pause it and see if you can figure this one out, and we'll come back. If not, I can get you started. You remember I said it had the equation had to be set equal to 0. For this one, I mentioned that in the last problem, just as kind of foreshadowing. So now it's set equal to 0. And it doesn't matter. The thing factoring, I would say divide by -1 right now all the way through. But because we're going to do quadratic formula, it doesn't matter whether A is positive or A is negative. So go ahead. I want you to see if you can set up the quadratic formula. Pause it. Go ahead and see what you get. And we'll check our answer together here momentarily. Okay, so we're solving this equation. X equals -b plus or minus square root b squared minus 4ac divided by 2a. So what is our b value? Our b value is a +2. We left it as is and didn't manipulate anything. So we get -2 plus square root of 2 squared minus 4 times -1 times -5, all divided by 2 times a -1. In imaginary solutions, you might be able to factor a problem that has imaginary solutions, or you might be able to use the completing the square method, but you cannot graph it. Remember, it doesn't. When we graph these equations, they don't cross the x-axis. You can graph all these all the way back and see how many times they cross, and if it doesn't cross the x-axis, you can't solve it by graphing. Okay, so let's simplify this. In our calculator, 2 squared minus 4 times -1 times a -5. Just doing the square root part, we get -16. Haven't gotten a negative number before. -2 plus or minus the square root of -16 divided by -2. So 16, -16, what do we do with that? We can't leave it as a -16, so we do a little math operation. We pull the I out, right? Do that math operation. I know you're all laughing at home. Okay, square root of 16 is 4. So 4i over -2. So -2, since both of these can be divided by 2, let's divide each of them separately. 4 over -2i, and we end up with 1 plus or minus, and really this negative with the plus or minus part is going to cancel out, so we're just going to say plus or minus 4 divided by 2 is 2i. So you can plug these answers back in, get a solution. You say 4 divided by -2, that's a negative, but it's kind of redundant because minus a -2 is going to be +2. And if we do plus a negative, that's a -2, so we don't really need that extra negative. If it makes you feel better, you go ahead and put that negative in front of the 2, but it's redundant with the plus minus aspect. Okay, so those are the 3 possible solutions. What happened? We got an imaginary solution this time. What was underneath the square root? It was a negative. So a negative part underneath the square root sign, that gives us an indication that there's 2 imaginary solutions. So, the discriminant, that's the name for the underneath the square root part. Remember, x equals -b plus or minus square root b squared minus 4ac divided by 2a. That's where this comes from. That's the discriminant. So we have a name for it now. You don't have to call it the part underneath the square root anymore. It is the discriminant. So, if it is a positive number, b squared minus 4ac, okay, b squared minus 4ac is bigger than 0, then the graph does something like this. It crosses the x-axis in 2 spots. If it is equal to 0, if b squared minus 4ac equals 0, then our graph looks something like this. It touches once. Or it's flipped upside down, touching once. It doesn't matter. It just touches one time. If we have a negative, then it's b squared, or negative discriminant. B squared minus 4ac then would be smaller than 0. And when we graph it, it's completely above or completely below the x-axis. I'll drop below this time. So the other one above. Okay, so that's the situation we have. So the discriminant kind of doesn't tell us what the solutions are. It's just going to tell us, hey, we're going to have positive, or we have 2 if it's positive. We're going to have 1 if it's 0. We're going to have no real solutions if it, or 2 imaginary solutions if we have a negative discriminant. Okay, let's look at this example. How many and what type of solutions will there be for the following equation? Now, we could graph this and see if it crosses or not. Okay, so I would suggest checking that, but let's just use the discriminant method now. Then I want you to go back, plug it in your graphing calculator, and see what happens. So what's b? b is negative 8. Minus 4 times 1 times 17. So we just plug this in our calculator just like we had been previously. It's just we don't actually have to find out what the solution is. We're just going to determine how many there are. So we're going to find the discriminant first. If the question asks you to find the discriminant, this is what it is. Plugging it into b squared minus 4ac. Times 17. And we enter. We get a discriminant of negative 4. So if we have a negative discriminant, what's that tell us? 2 imaginary solutions. Look back on the previous slide. Look back on your notes. Negative b squared minus 4ac is 2 imaginary. That means it doesn't cross. So if we graph this real fast, we'll graph this one. Y equals x squared minus 8x plus 17. Well, that one's already in there. How convenient is that? We already looked at that one. Let's graph it. Does it touch the x-axis? It does not. So there's proof in the picture. There's 2 ways to look at it. You graph it. Got that big box here, huh? Shrink it down. Let's move it down here. Anyways, that proves it doesn't cross the x-axis. Okay, the discriminant and the graph should match up and point in the right direction. Now, our solution is not negative 4. Don't confuse that. That's what the discriminant is. We'd have to go through the whole quadratic formula. We'd have to do the b opposite of b plus or minus negative, the square root of negative 4 over 2 times 1. Okay, so this just tells us how many solutions there are. Why don't you guys pause this one, you try that, and then we'll come back and we'll check it with the discriminant real quick and see if you get the same answer. Okay? Okay. We don't have to do too many of these, but just to give you the idea, let's look at the discriminant, see what we get. That's going to tell us how many solutions we have. 4 squared minus 4 times 1 times 3. 4 times 1 times 3 is 12. 16 minus 12 is 4. It's positive. If you look back in your notes, that means there's 2 real solutions. If we graph this equation, it's going to cross. It's going to cross. That means implies. It's going to cross the x-axis twice. So let's graph it real quick, and we'll wrap it up for today. X squared plus 4x plus 3. Just graph it. Oh, remember, we're just seeing how many solutions they have. We're not looking to find how many solutions there are. We're just going to see how many they have, and we can see it crosses the graph twice, 2 real solutions. Okay? This one, if you want to try this one on your own, give it a whirl here, and check it real fast, in case you still need extra practice. How many, what type of solutions? B squared minus 4AC. B is 2. Negative 1 is A. Negative 1 is C. We get 4. Negative 4 times negative 1 is positive 4. Positive 4 times negative 1 is negative 4. Negative 4 minus 4 is 0. That implies what? What does that imply? It implies that there is one real solution. So I'll let you graph it. You'll see that it only touches the x-axis one time, and that's that. So today, hopefully we hit both these targets. You look over your notes. What do you think? I feel pretty confident that we are now able to use a quadratic formula to solve a quadratic equation. And we now learn that the discriminant, which is the b squared minus 4ac, the part of the quadratic formula under the square root, we can use that to tell how many solutions we're going to have. And it should match up to what the graph looks like. So hopefully what we've learned throughout this chapter is there's way more than one way to solve a quadratic equation. And using multiple methods to check and or solve it are going to help to ensure you have the right answer. When we take our end of the unit assessment, you're going to have to just pick the method that works for each individual situation. I'm not going to be able to tell you use quadratic here or use factoring here. You're going to have to look at it and decide which method you can use. So be comfortable with all of them. Try and evaluate the problems as you go through it. Is this one I can factor? Is this one I can use a quadratic formula when you're reviewing for the test? And it's going to make your life a lot easier. Obviously, my favorite method to use after going through this and teaching would be factoring. It's the fastest method. Followed right up by graphing, because you can use your graphing calculator. That helps you do it really quickly. Values that don't come out nice in the graphing calculator, that's where completing the square and or using the quadratic formula, those come in handy. The quadratic formula just there's lots of pieces to it, so sometimes people miss a minus sign here and their answer comes out wacky. So quadratic formula works, so it's kind of a backup method. Make sure you have everything in your notes. If you miss anything, go back, rewind, look at it over again. Remember, you don't have to look over the whole thing. You can fast forward, pause, whatever you need to do, and we'll see you with your notes in class tomorrow.